Hello, Madam Hazani. This is our group. We got question 5. Before that, let me introduce myself first. My name is Barbara Bakulena Noma.
My name is Mary Senasnana Hendriden.
My name is Eliseo Sodapa.
My name is Ezekiel Ryan Ryan.
Hello, my name is Alexius. Today I want to explain the question 1. The question 1, for the first, we must read the question carefully to understand all the statement and what the question want we to do. I was represented in this question. The tick exercise book is represent for X and the tin represent for Y. Also in this question, the price of the tick one is RM 2.50 and the tin one is RM 0.70. That is the price. After that, we also must to find another information that question give. And the other information that we can take is the tick one is 4 more from the tin one. After that, we also know that total of the process is 26 ringgit. That is the all of information that we can gather from the question. Now let we move to the first question. First question is one way to state two linear equation that we can find in the question. For the first one is x minus y same with 4. The second equation is 2.5 minus 0.70. This is 70, guys. And the total is 26. But we don't want this. We must change it to the solid number. To change it to the solid number is we must multiply this to 10. This also to 10. And the final answer is 2050 minus 7 same with 260. That is the linear equation that we can find in the statement. Then we move to the second question. The second question one way to find calculate the value of x and y using the Cramer rules method. To do this question, we must use the linear that we have find in the first question. The equation that we find is x minus y same with 4 and 250 minus 7. This is the two equation that we find in the question 1, and we must use this to do the question number 2. For the first, we must put it in the bracket first. How to do it is x, the x mean it present 1 and y also present 1, and don't forget the negative, we must bring it, and this also we put in and 7. Make the bracket for the matrix. This x, y, the matrix. This x, y, 4. Sorry for the bad tulisan. From the equation, from the matrix that we write, we must find the determinant. For the first one, determinant is A, B, C, D. This is the formula. A multiply with D, B multiply with C. And how to write it is 1 per 7 minus negative 1 per 25. 25. To find the first determinant is 1 multiplied with 7 minus negative 1 multiplied with 25. And the answer is 32. This is the first determinant. And after that, we find the determinant x. Determinant x is E, F, B, D. That means we replace the first column with this. We put it to the matrix to find the determinant x. How to do it is to find the determinant x. How to do it is we write again 4, 20 to 60 and negative 1 to 7. is the same. It was the same formula. We must multiply it like this. 4 minus multiply with 7 minus negative 1 to 60. The answer is 288. Then we move to find the next determinant. After that, we must find the determinant y. The way to make it is we must replace the e and f to this matrix. We put 4 and 260 into it, and this still the same like the first matrix that we make. This is 25, and we also must multiply it like this. 1 260 minus 4 25, and we get the final answer is 160. Then to find the x is we must do this rule, determinant x per determinant 0. It means x same with 2x per 32, and the final answer for x is 9. That is also the same like we to find the y. We must use the same way how we find the x. In the top we use determinant y, and below we use the determinant theta or 0. That means y same with 160 per 32, and the final answer is 5.
Hello, my name is matrices. So let me continue to the question B. In this question, we need to solve this using a inversion method. Given 3 linear equations, so first we need to move it into the column, which is the first column is x, second is y, and third is z. Next, we need to put the alphabet and the answer like this. So next, we need to find the determinant of this question. So the formula is plus minus plus. So this is how we get the final answer. We are using a formula a minus d, a times d minus b times c. So for each book we need to minus it. For example, negative 6 times negative 1 minus 6 times 3. So the answer is negative 1. So next, after we find the determinant, we need to find the common factor for C. For this calculation, we need to use a formula plus minus plus for the first line. Then for the second line, we use minus plus minus, and for the third is plus minus plus. Next, we use again the formula a minus d, a times d minus b times c for each book. And now this is the full calculation and the final answer for common factor. So next I will pass the explanation for my to my friend, which is Barbara.
Okay. Before that, let me introduce myself first. My name is Barbara Makulena. Now, let me continue what the Marciana just now explained. Okay, given that the metric is this, then first we need to find the adjoint of matrix. The adjoint is obtained by taking the transpose of the converter matrix. In this question, the adjoint matrix is equal to 3, -2, -3, 0, -1, -2, 4, -3, and -5. That means the row are changed into the column. Next, we need to use the inverse formula. The inverse formula is a -1 equals to 1 over determinant a join 6 the determinant is -1, so we need to put it into the formula. So right now we need to multiply by -1, change all the signs. So this means, so the answer is -3, 2, 3, 0, 1, 2, -4, 3, and 5. So now we need to explain of the multiplication part. The matrix is multiplied by the factor, which is 1, 1, 1. So calculate each row. First row is 3 times 1 plus -2 times 1 plus -3 times 1. So the answer is -2. Second row is 0 times 1 plus -1 times 1 plus -2 times 1. So the answer is -3. Then the third row is 4 -1 plus -3 times 1 plus -5 times 1 equal to -4. So the result is -2, -3, and -4. Then we need to multiply by 1 over -1. So the answer is 2, 3, and 4. So that's it. Thank you.
Okay, so hi, madam. So my name is Ezekiel Ryan. So I will prove the following law of matrices. So A, wait. So A multiply by A inverse equal to A inverse multiply by A equal to identity. Okay, so here my A I will here the A is my A is 2, my B is 1, my C is 5, my D is 3. And so guys, my A, so here you can choose any number So for me, I will choose for my A is 2, my B is 1, my C is 5, and my D is 3. So so if we want to find the inverse, we must use the following formula for the inverse: 1 per AD minus BC, and followed by the matrix form, which is 2 1 5 2 1 5 3. Okay, so next, for the matrix form, we must change the position. For example, A inverse 1 per AD minus BC. Change position from A to D, and wait, I give some example from A to D, and for B and C we just add negative. So next, for the matrix form, we must change the position. For example, we must change the position. Minus 3, negative 1, negative 5. So for the A inverse, 1 per AD minus C, which is 2 times 3 minus 1 times 5, 5, and followed by the matrix form, which is 3, negative 1, negative 5, 2. So after that, we just multiply it. So the answer for A inverse 1 per 1, 3, negative 1, negative 5, 2, 5. So the final answer, it will be 3, negative 1. Wait. So the answer for A is 3, B is negative 1, C is negative 5, and D is 2. Okay. Next, we will find the answer A multiply by A inverse. So that, which is 2, 1, 5, 3, multiply by 3, negative 1, 5, 2. So how to solve this question? We just multiply it. I will give some example. So 2 times 3 plus 1, 5. 2 plus 3 plus 1 multiplied by negative 5. Second, 2 times negative 1 plus 1 multiplied by 2. Third, 5 multiplied by 3 plus 3 multiplied by negative 5 plus 5 negative 1, 5 multiplied by negative 1 plus 3 multiplied by 2. So the final answer should be 1. For the A is 1, for the B is 0, for the C is 0, and for the D is 1. A inverse multiplied by A, we just change the position. Like, for example, 3, negative 1, negative 5, 2. We just change the position to 5. Here, 3 multiplied by 2 plus negative 1 multiplied by 5, 3 multiplied by 1 plus negative 1 times 3, negative 5 times 2 plus 2 multiplied by 5 plus negative 5 times 1 plus 2 times 3. So the answer, we also get the same answer with the previous slide, which is 1, 0. Based on the final answer, as we can see, since both A multiplied by A inverse equal A inverse multiplied by A equal I identity, so give the exact same identity matrix, which is 1, 0, 0, 1 identity. So here, since both A multiplied by A inverse and A inverse multiplied by A give the exact same identity matrix, which is for the A 1, B 0, C 0, and D is 1, this proof that the calculated inverse is correct.